Thanks for joining me again. We are moving on to one-sided limits. So in the previous video, we learned about limits in general, and now we're going to learn about something called one-sided limits. So again, this definition is straight from the textbook, and it defines a right-sided limit, or a limit from the right, and a left-sided limit, or a limit from the left. And I'm going to break down these definitions. So for a limit from the left, the textbook says, let f of x be a function defined at all values in an open interval of the form c, a, and let L be a real number. If the values of the function f of x approach the real number L, as the values of x, where x is less than a, approach the number a, then we say that L is the limit of f of x as x approaches a from the left. Symbolically, we express this idea as the limit as x approaches a from the left, f of x is equal to L. So what does this mean? Well, again, this first part is defining f of x as a function, and it's defined at all values in the open interval. That just means that the points c and a themselves are not included in this interval. So we have a function that's defined on an interval, and we still have this L that is a real number. It's the y value in this ordered pair. Then it says, if the values of the function f of x approach the real number L as the values of x approach the number a, then we have this limit. So this is our limit from the left. So what this means is that if I approach a from the left, so if I'm on the left side of a, and I look at what's happening to my graph, in this case I'm on this piece right here, then I am approaching, in this case, 8. So 8 is this L value for when x is approaching a from the left. So we would write the limit as x approaches a from the left of our function f of x here is equal to L, which in this case is the number 8. And then we have a similar definition for the limit from the right. Of course, this time we're on the open interval from a to c, but everything else stays the same. We have this function f that's defined on this open interval, and this time we are approaching a from the right side. So now we are on this side of a in terms of the x values, and that means that we are on this other piece of the graph. This is a piecewise function. So now we're on this other piece, and it approaches a different L or y value. So for this case, we say that the limit as x approaches a from the right, we denote that with a little plus sign at the top, of f of x is equal to L, which in this case is 6. So when we are dealing with one-sided limits, it is not unusual for the right-sided limit and the left-sided limit to have two different numbers, in this case 8 and 6. That's because this is a piecewise function, so we have a different number for the left and the right-sided limits. So let's look at this other graph down here and evaluate the left and the right-sided limits of this function. So here we have this function f. It's defined on all of the intervals that are important to us, except for, here, of course, but it's that point is taken care of by this point here, so that doesn't really matter. So let's evaluate the limit as x approaches 2 from the right and the limit as x approaches 2 from the left of f of x. So if we look at the limit as x approaches 2 from the right, that means, here's 2, that we are approaching x equals 2 from this side. And which piece of the graph are we on? We're on this linear piece. And as x gets really, really close to 2, our y value is getting really, really close to 8. So the limit as x approaches 2 from the right of f of x is equal to 8. And if we look at what's going on the left side of 2, here we're approaching x from the left, x equals 2 from the left, and now we're on this quadratic portion of the graph. These y values are corresponding with the x values below. This piece of the function, y value is approaching 6. So we will write the limit as x approaches 2 from the left of f of x is equal to 6. I'm just now noticing that we have the same numbers here, but that was not intentional. Of course, not all of the limits will always be 8 and 6. But yeah, this is how we can look at a graph and determine the right and left-sided limits. I think it's helpful to kind of draw these arrows to see which x values we're looking at and which y values correspond to those x values. Let's look at a table now. So looking at this table, we want to evaluate the limit as x approaches -2 from the right and from the left of f of x. So if we are looking at this table here, right here is the point -2 in between these 2 points here. And on this side, we are approaching -2 from the left. And on this side, we are approaching -2 from the right. If it helps you to draw a number line and kind of sketch it out, that works too. So as f of x gets really close to -2 from the right, limit as x approaches -2 from the right, what's going on with those y values? Well, we see that we are approaching the number 5 as we approach -2 from the right. So this would be 5, and this limit as x approaches -2 from the left, now we're on this side of the graph, and it looks like it's getting very close to 0, right? We're getting really, really close to 0 as we approach the x value -2 from the left. So I'm going to write the limit as f of x, the limit as x approaches 2 from the left of f of x is equal to 0. So this is all about right and left-sided limits.